Welcome to example number 8. And you might find there's a variety of ways of doing this problem, so my suggestion is try on your own and then maybe take a look at the video if you need to. Here's just one way of doing it. Part A is asking for the angular velocity of your tires. Now the tire has a diameter of 0.6 meters. So that means the radius would be half of that. So 0.6 meters divided by 2, which gives you 0.3 meters as your radius. You're asked to find the angular velocity. So really what you're looking for is omega. And if you recall, the relationship between the tangential velocity and the angular velocity is simply take the angular velocity multiplied by the radius. Therefore, if you want to find the angular velocity, really just take this velocity that your tire is going at, the velocity of the center of the mass, and divide that by the radius. Now, the velocity in this case is given as 72 kilometers per hour. And that's great, but we want our angular velocity to be in radians per second. So we're going to need to convert this into meters per second. 1 hour, we have 3,600 seconds. So our hours will cancel out. And then in 1 kilometer, we have 1,000 meters. That will give us a velocity of exactly 20 meters per second. So therefore, now we plug it into our angular velocity equation, which is 20 meters per second on the top, divided by the radius, which is 0.3 meters. And that will give you 66.76666 onwards. So I'm just going to round that off to 67 radians per second. So that's part A. Part B, you need to find out how many revolutions it makes. Now you do know how many radians it's covering per second. We don't know how much long it is. Now we do know that your car travels 100 kilometers for the trip and is traveling at an average velocity of 72 kilometers an hour. So my thinking is this, and there might be a variety of ways of doing it, is that since we already know the angular velocity in part A, that's related to the change in the angle, change in theta, divided by the change in time. So we can find the amount of radians it covers, and we can find the number of revolutions or turns it makes. So delta theta is equal to the angular velocity multiplied by the time that it took for the trip to be completed. So we're going to need to find the time that takes the trip. So the average velocity, if you remember back, just really velocity equals distance divided by time. We could solve for the time that took the car to make the trip. So that would be the displacement divided by the average velocity. So you went 100 kilometers an hour, which is going to be really 100,000 meters multiplied by 1,000. Divided by the average velocity, but we want that to be in meters per second. So we're going to use 20 meters per second. That's what 72 kilometers an hour is equivalent to. So that will give us a time period of 1,000 seconds. It's about 1.38 hours, but we want it in seconds because our angular velocity is in radians per second. So then our change in theta will be equal to 67 rads per second multiplied by 5,000 seconds. And that will give you a change of the angle of 333,333 radians. But we want it to be in revolutions or turns. In one turn, we have 2 pi radians. So we're going to divide this answer by 2 pi radians. And that gives us an angle of, or number of turns of 53,052 turns, which we'll just round off to 53,000 turns. Okay, that's it for example number 8.